Why are there not more people talking about the forgotten innovations that shaped World War II? If you love uncovering hidden history, make sure to subscribe, like and share, so you never miss a story that changed the world. Steel was the skeleton of World War II. Every tank, ship and rifle depended on it. The demand was colossal. Nations poured their economic might into steel production, knowing it was the currency of military power. But as the war dragged on, steel became terrifyingly scarce. Mines were exhausted, factories bombed, and supply ships sunk. Planners faced agonizing choices: tanks or ships, artillery shells or bridges. The shortage threatened to grind the war effort to a halt. Desperate for alternatives, engineers turned to wood, plentiful, cheap, and easy to work. Suddenly, wood was used for training aircraft, vehicle frames, and fortifications. But everyone knew wood was a poor substitute for armour. It offered little real protection. A wooden barricade might conceal a soldier, but it couldn't stop bullets or shrapnel. The war's hunger for steel had created a terrifying vulnerability. A solution was needed, and it would come not from the foundries, but from the world of chemistry. An unexpected form of salvation was about to emerge. In war, an object's failure can be as deadly as enemy fire. Untreated wood, when struck by bullets or shrapnel, shatters violently, sending razor-sharp splinters flying. These secondary projectiles turn makeshift shelters into deadly traps. Medics dreaded these wounds. Deep, ragged and prone to infection, soldiers lost faith in their cover, knowing it could betray them at any moment. Imagine a guard post of timber and sandbags. Bullets tear through, and the real danger comes from the storm of splinters inside. This scenario played out again and again, a tragic flaw in using wood for defence. The problem extended to vehicles, boats and aircraft, anywhere wood replaced steel. A strafing run could turn a boat's deck into a field of spikes, maiming the crew. The need for a solution was urgent, not just for stronger walls, but to neutralize this hidden danger. Troops needed safety and confidence restored. The answer would come from chemistry. The breakthrough came from chemistry sodium silicate, or water glass. This clear, syrupy liquid had long been used for fireproofing and preservation. When applied to wood, it soaked deep into the fibres. As it dried, it reacted with air to form a glassy matrix within the wood structure. The result, wood that was harder, denser, and, crucially, resistant to shattering. Instead of exploding into splinters, treated wood absorbed and distributed impact. Bullets might still penetrate, but the catastrophic spray of shards was eliminated. The treatment also made wood fire-resistant, a vital bonus in a world of incendiary weapons. Structures would char, but not burst into flames. Sodium silicate became a true miracle paint for those who depended on it. The genius of sodium silicate was its simplicity. No special factories were needed, just a bucket, a brush, and a drum of solution. Soldiers could treat bunkers, guard posts and vehicles right in the field. Multiple coats built up a robust glassy shield inside the wood. In less than a day, a vulnerable wall could become a hardened defence. Anything wooden, trucks, crates, bridges, could be protected. This hands-on process empowered soldiers, giving them control over their own survival. The miracle paint became a standard tool, boosting morale and saving lives. It wasn't just technology, it was a shield they applied themselves. In a war of industrial might, this simple act made a world of difference. The real impact of hardened wood is found in stories from the front. On the Eastern Front, a machine gun nest treated with sodium silicate withstood direct fire. No deadly splinters, no casualties. In the Pacific, bunkers with silicified logs survived mortar barrages, saving entire squads. Treated wooden bridges in Italy survived strafing runs, keeping vital supply lines open. Truck drivers told of bullets and shrapnel that left only neat holes, not showers of splinters. These weren't grand victories, but countless small moments of survival. Each story multiplied across the war, saving lives and momentum. Hardened wood was an unsung hero, quietly altering the odds. It was innovation at its most practical. And for many, it meant the difference between life and death. At sea, chemically hardened wood played a silent, heroic role. Navies built fleets of wooden patrol boats and landing craft to save steel, but their crews faced deadly splinters. Sodium silicate became standard decks, bulkheads and gunnels were meticulously treated. On torpedo boats, this shield was often the only thing between life and death. One Royal Navy sub-chaser survived a strafing run. Shells punched through, but the deck didn't shatter, and the crew survived. For landing craft, treated ramps and sides gave soldiers precious seconds of cover during invasions. A ramp that held together under fire could save dozens of lives in a single moment. The hardened wood didn't make these vessels invincible, but it gave crews a fighting chance. Sometimes survival depended on a simple chemical shield, and that shield changed the course of battles. After the war, steel was plentiful again, and the need for hardened wood disappeared. Industries returned to steel and advanced alloys, stronger, more durable, and purpose-built. Hardened wood was a product of necessity, quickly forgotten as new materials emerged. It lacked the glamour of radar or the atomic bomb. No famous inventors, no headlines. Its story lived in field manuals and soldiers' memories, not in history books. Soon, fiberglass, polymers and composites replaced even the best treated timber. In military technology, wood became obsolete. Yet the principle, enhancing common materials for survival, remains vital. Today's composites and advanced materials owe much to this wartime ingenuity. The lesson endures. Necessity drives innovation. The story of hardened wood is a lesson in survival and progress. True innovation often comes from scarcity, not abundance. WWII's soldiers and engineers didn't wait for perfect resources. They adapted, creating something remarkable from the ordinary. The war was won not just by tanks and ships, but by clever, immediate solutions on the ground. A simple chemical on a plank of wood could save a life. Today, as we face new global challenges, this mindset is more relevant than ever. We must be resourceful, finding value in overlooked materials and clever solutions. The future depends on countless small adaptations, not just miracle resources. The forgotten story of hardened wood celebrates human creativity in adversity. Our greatest resource is, and always will be, our own ingenuity.